again for joining us today in Mathcon universe and the wonderful world of mathematics. Today, our focus will be on strategic problem solving in key concept of absolute value linear algebraic inequalities. Again, our focus will be on strategic problem solving in key concept of absolute value linear algebraic inequalities. Let us get started right away. So our goal today will be to solve and graph this absolute value algebraic linear inequality. Absolute value linear algebraic inequality problem. So what will be our first step in this strategic problem solving process? What will be our first step? Well, let us see. Our first step will be to use what we call the distributive property. Distributive property. Step number 1. Use the distributive property. In other words, if A, B, and C happens to be any real number on the number line, where A, B, and C can represent any of the numbers on the real number line, this property says to do something. Distributive property. Distributive property. It says, given A, B, and C, where A is into B minus C, take A and multiply B, and take A and multiply the negative of C, which is the same thing as A times B minus A times C. I repeat, A times B minus A times C. A times B minus A times C. So, how do we use this property in this problem? Well, we are going to connect the A with the 3, the B with the X, and the C with the 2 in our problem. So that means that we're going to take 3 and multiply X, and take 3 and multiply the negative of 2. So that means that we're going to get 3x minus 6. 3x minus 6, 3 times x equals 3x, and 3 times negative 2, negative 6. And then we need to bring down our absolute value symbol, and of course bring down the greater than symbol, and bring down the 9. So what will be our next step in this strategic problem solving process? At this point, we are going to use a famous law in algebra. A law is also known as a rule. So let us see. So we can call this the rule or law of absolute value. Inequality. What does this law or rule say? what does it say? It says that if the absolute value of S is greater than T, I repeat, if absolute value of S is greater than T, then S is greater than T, or S is less than negative T. I repeat, if S is greater than T, then S is greater than T, or S is less than negative T, where S is a real number on the number line and T is a real number on the number line. So in our problem, our S will be 3x minus 6, our T will be 9. So therefore, we are going to be able to write this inequality as 3x minus 6 is greater than 9, or 3x minus 6 is less than negative 9. So in order to obtain the solution to this absolute value inequalities, we must solve these two linear inequalities. So let us do so at this point. So what will be our first step in solving this inequalities? Let us solve the first one first. Notice we have negative 6 on the left side, and we need to do something about this negative 6. In order to be able to solve for x by itself, to isolate x, we must move the negative 6 to the right side of the inequality. And remember that whenever we move any quantity across a sign known as equal inequality or equal sign, the sign of that entity must change. So therefore, the problem now becomes 3x is greater than 9 plus 6. So what is 9 plus 6? 9 plus 6, of course, is 15. So that means we have 3x is what? Greater than what? 15. So 3x greater than 15 means what? That x is greater than 5. X is greater than 5. How did we get this? Well, we, of course, have to divide both sides by 3 in order to obtain x is greater than 5. Notice that the inequality was not reversed because we were able to divide by what? A positive number, namely the number 3. If we had used a negative number to divide both sides of the inequality, this inequality would have been reversed. So let us go next to solve the second inequality. How do we solve the second inequality? Again, we are going to use the same strategy we used in solving the first one, inequality. So therefore, at this point, we are going to move, again, the negative 6 to the right side of the inequality. And by so doing, the negative becomes a positive. So therefore, we are going to have to write 3x is less than negative 9 plus 6. I repeat, we're going to have 3x is less than negative 9 plus 6. What is negative 9 plus 6? What is negative 9 plus 6? Well, negative 9 plus 6, of course, is going to be negative 3. Negative 3. So that means that 3x is less than negative 3. If 3x is less than negative 3, what will x be? Notice, again, we are dividing both sides by a positive quantity. So therefore, x, of course, will be less than negative 1. X will be less than negative 1. X will be less than negative 1. So we have been able to obtain two solutions. One of the solutions, of course, is that x is greater than 5. And the second solution, of course, is that x is less than negative 1. So what will be our next step in this strategic problem solving process? Our next task or next step will be to graph the solution that we have just obtained on a real number line. And that is how we can obtain the graphical solution for this problem. So let us do so at this time. So let us do so. Notice the famous number 0 is a number that is right at the middle of what we call the positive numbers and the negative numbers. Positive numbers to the right, negative numbers to the left. So let us go ahead and pick some numbers here. So we have number 1 here, number 2, number 3, number 4, number 5, 6, 7, and 8. On the left side of the number 0, of course, we are going to have negative 1, negative 2, negative 3, negative 4, and negative 5. So now let us go ahead and draw this graph to obtain the graphical solution. So where will x greater than 5 be? Well, we are going to pick the number 5 here, of course. And because the solution says that x is greater than 5, we are going to shade every number greater than what? 5. Greater than 5. So every number greater than 5 is a solution to this inequality. But 5 is not a solution. Notice that every number less than -1 is a solution. -1 is not a solution, but every number to the left of -1 is a solution to this inequality. So here we have what we call the graphical solution. The graphical solution. The graphical solution of the problem, of the absolute value problem. Absolute value inequality problem. Thanks again for joining us in Mathcon Universe and the wonderful world of mathematics. Until next time, bye-bye.